So this is the ECG signal. What can we tell from ECG signal? So first, of course, heart rate. We can get heart rate by looking at looking at the intervals between the peaks. Then we can also get heart rate variability, HRV. So high HRV reflects better resilience. That means our heart is better able to respond to or adapt to, like physical or mental challenges. So, high HRV reflects, better resilience of the cardiac system. Then, we can get this too, but we can also get respiratory rate from ECG. So how can we get respiratory rate from ECG? Look at this graph. So can you see any features of respiration? Yeah.
Like the longer wavelength wave that it's oscillating at.
Yeah. So are you referring to this?
Yeah.
Yeah. So this is your respiration cycle. But why is this? Why is respiration affecting ECG? Go ahead.
Does it have to do with the movement of your chest or no?
You are very close. Can you explain in more detail?
Like your lungs are expanding?
Yes.
And then that could affect the electrical impulse.
Yeah, you're right. Oh, go ahead.
Is it because the lungs move the heart closer to where the electrode is?
Okay.
Yeah. Okay. That's exactly the reason. So your chest movement changes the distance from the heart to the electrode. So that changes impedance. So that's why you get respiration is modulating the amplitude of ECG. Okay, that's great. So okay. All right. So based on ECG, we can detect heart disease like myocardial infarction, ischemia, or a lot of conditions. We can also detect mental state. So there's a paper that on this. So what they find here is you have different ECG when you're happy, sad, then you can throw everything into a neural network. Then you can tell their mental state. Just very probably very preliminary demonstration, but this is a good direction. Okay, so we also talk about EMG. So this is the electrical signal of the muscle. Then you can have an array of electrodes on the skin. Then depending on how you move your fingers, depending on which finger you're moving and how many fingers you're moving, based on EMG, you can actually detect gesture. So this can be a way for gesture recognition. You can even measure EMG and throat. So because when we speak, our muscle at the neck is moving. So by looking at the EMG, we can infer very simple speech. And this is useful for people who lost their language function. So those people still know how to speak, but they just cannot make sound, right? So by looking at EMG, we can help them, to do simple commands. So we can also use the electrophysiology for brain-machine interface. This is a very simple demonstration. They pattern, ET2, near the brain. Then they can measure ECG. Based on patterns in ECG, they can convert those patterns into commands and use, those commands to solve a maze. This is a very simple demonstration, but it shows that, based on brain waves, we can develop a brain-machine interface. That's the kind of things you see in science fiction, right? So this is a very simple demonstration. So for more complicated, brain-machine interfaces, you need better spatial temporal resolution. So often you need to implant electrodes into the brain. So that's this kind of thing a lot of people are doing, including Neuralink, if you know.